For those of you keeping score, you'll notice this says Nomenclature 5, and if you look back, there's only 3 previous, and that's because in week 4, or layer 4 if you will, we do a couple of other things, and I'm not going to do a video for that one. At least I have no plans to. Okay, it says classical nomenclature, classical metal, non-metal nomenclature, so we need to kind of get a handle on what that means before we understand how the nomenclature works. So, all previous nomenclature stays the same, you know that. And what we've done so far, for those of you who are keeping score, is we've done the always metal, non-metal nomenclature. We've done the other metals where we're using a Roman numeral, and we've done non-metal, non-metal. And we've probably done one other thing, but it wasn't really worth doing this for. Okay, what do I mean by classical? If you think about the history, we had a bit of an understanding, we started to understand atoms in around the 1800s. That was when we had the first atomic theory, John Dalton. Before that, though, we discovered compounds, and we had identified compounds, we had identified elements. And a lot of them, those compounds, we started to identify them or understand them based on mass ratios. So we didn't know how many atoms there were, but we knew that how the masses compared between the different elements. So, for example, in the case of iron and sulfur, we knew that there were 2 possible compounds. One we now know of as iron, Roman numeral 2 sulfide, and the other one is iron 3 sulfide. We now know the formulas, and we now know those little numbers mean how many atoms there were, but what would you do before you had an understanding of atoms? What they did have before they understood atoms was they knew that one had a higher proportion of sulfur in terms of how the mass ratios worked out. So you didn't need to write any of this stuff down. Sorry for telling you at the end of it instead of at the beginning of it. But that's how the stuff worked. So we didn't know about charges, and we didn't know about numbers of atoms. We knew about masses. Now I realize that sounds like it's going to be a lot of work, and it was for them. It's not going to be for us. But the bottom line is a lot of the elements that we know of have 2 possible charges. So unlike ones that only have 1 possible charge, and unlike Roman numerals that say we don't know how many charges, there were some that had 2 possible charges. Now if they have 2 possible charges, obviously one is going to be a higher charge, the other is going to be a lower charge. So the type of nomenclature that we're looking at today recognizes higher and lower. It doesn't tell you automatically what the higher charge is or what the lower charge is, just bigger, smaller, higher, lower. The higher charge, we're going to end with the suffix "ic", and the lower charge will end with the suffix "us", O-U-S. Now, a couple by the way. Back in that day, when some of this stuff was being done and developed, the scholars were using Latin. And I'll tell you at the beginning, almost, you don't need to write this down either. But the names of elements were also, a lot of them anyway, were Latin. So this stuff will use Latin names. My preference, and I'll call it Alchemist nomenclature, and that's because when I learned it from a pretty awesome chemistry teacher, Mr. Dave Lamble, he taught it to us as Alchemist nomenclature, and that's what I've kind of stuck with. It's never really caught on as a name. Maybe we can make something happen. Hashtag Alchemist nomenclature. But regardless, whether you go to the textbook where they call it classical, or whether you're looking at me, which is carrying on a tradition from a really great guy, Alchemist nomenclature, either way, we're going to use it the same way. Okay, looking at your periodic table, find these elements. They're going to be 26, 27, 28, all in a nice tight little group. If you were to look at all the compounds known of those things, you would find that they would have a charge of either +2 or +3. Some have preferences. We're not going to worry about it. But the names we're going to use to recognize that is ferrous, cobaltous, nickelus for the lower charge, anytime they're doing +2 compounds, ferric, cobaltic, nickelic whenever they're doing +3 compounds. Moving on, copper and mercury, so one is in group 11 at the top, one's in group 12 at the bottom, they will have possible charges of +1 or +2. And again, if for one we use a Latin name, for the other one we could use a Latin name, but most people will call it mercury, mercurus and mercuric, cuprous, cupric. Gold, right beside mercury, just to the left of it, has possible charges of +1 and +3, aurous, auric. Moving over into group 14, near the bottom, you'll find tin and lead, SN as PB. +2, +4 charges are possible. And we go with stannus, stannic, plumbus, plumic. By the way, the B in plumum is silent, but because most of the nomenclature that we do is written, if you want to pronounce the B instead of plumus and plumic, okay, if it gets you to spell it right, even better. And then the last two that we're going to pay attention to are in group 15 near the bottom, antimony and bismuth. SB for antimony comes from the Latin that we're going to use as stibanus and stibanic, and bismuthus, bismuthic. Possible charges are +3 and +5. Okay, we use it the same way because those suffixes tell us something about charges as long as we know what the charges are. So take, for example, ferric sulfide. Well, I know that ferric means higher charge, and I know that the higher charge for iron is +3. So in other words, I know what the charge in iron is. I don't have it obvious in the name as a Roman numeral, but I have it close to obvious, whatever one level down from obvious would be. So that means we're going to treat this stuff as, because it is, the same thing as iron 3 sulfide. And I already know how to do that. I can do the crossover reduce stuff. If I had a formula, SnBr2, well, I'm going to start with my nonmetal. I know that my total negative charge is -2 because bromine is in group 17 and it's always -1 with metals. That means I must have a total positive charge of +2, which for tin is the lower charge, so I'm going to call it stannus. That's it. So getting a little bit of translating going on, sort of a one extra step in each case over and above what I would do for Roman numerals, but other than that, it's no different. A couple of final thoughts before we go. Number one is that, and you don't need to write this down, but if you look at what the lower charges and the higher charges were, there's quite a range. And what that means is if I have a metal that ends in us, lower charge, but it doesn't really narrow it down. If I have a higher charge, ic, narrows it down even less. So I need to know what those charges are. So iron, for example, +2, +3, +3 is the higher charge, but for antimony, +3, +5, that same +3 is the lower charge. So knowing ic doesn't tell me a whole lot unless I know this extra piece. Second thing is that it's not officially recognized. If you were to look at the big book of rules of nomenclature in chemistry, this stuff isn't in it, but it's very, very common. It's kind of like a slang, and a lot of people use it. So to have an intelligent conversation with somebody about compounds, which is kind of a funny idea, you would need to at least understand this kind of nomenclature. Anyhow, I hope that helped, and next time we'll keep